Okay, how you doing? I'm Mr. Boyett, and I'm going to be talking about the scientific method today. Now, scientific method, any class you start off with in science, they're always going to be talking about the scientific method because it's the cornerstone of science. It's a lot of people don't really understand, but science is a process. It starts at point A and goes to point B, but there's many, many steps in between. And so usually if you see anything about scientific method, you're going to see steps that are like this. Now, these steps people whiz through in 1 second. I mean, in your mind, you're going to see when I go through this that you constantly do this. Every person out there is a scientist, and we all use the scientific method constantly. We just don't realize it. And so for me to write down these steps and for you to try to memorize them is kind of ridiculous, but it's really neat to break these things down and see how they actually work. So let's go through it. First of all, observation. In order to do the scientific method, you have to already be observing something. You have to be inquisitive and look at things in a slightly different perspective. And a lot of scientists already do this, and a lot of young people as yourself already do this. And so a good example of this would be a good example of how people use the scientific method would be like if you come into your room and your light doesn't work. You turn on the light switch doesn't, the light doesn't come on. And that's a great example. So obviously you already made an observation. My light did not come on. And then you say, all right, well, what's the problem? I have a question. What's the problem? And now, in order for me to answer these questions, I have to have some kind of knowledge. I have to have some kind of knowledge of how electricity works. I mean, think about it. If you don't have knowledge, I mean, when you're 3 years old and you walk into your bedroom, you turn the light switch on and the light doesn't come on, do you say, I think I should change the light bulb or something like that? Of course not. Of course you don't do that. As a 3-year-old, the first thing you do is we all say what? We say, Mom! All right? And then so Mama comes and actually goes through the scientific method processes here, or the steps. And so knowledge, you have to have some kind of knowledge. So obviously you as a high schooler already have some kind of knowledge about how electricity works. Some of us more than others. Okay, so the next one, hypothesis. So first of all, what's the very first thing that you do whenever you come in and you turn on the light switch and it doesn't work? Most of you probably automatically say, oh, I'm going to change the light bulb. Well, actually, it's not the first thing you do. We all do the first thing the same way. The first thing is we flip the switch off and on. We think that maybe our knowledge tells us there might be something wrong with this switch. It might have a glitch in it, some kind of short circuit. And so your hypothesis says, if I jiggle this switch, then the light should come on if it's a bad switch. And so then you do your experiment. Click-a, 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 right? And so now you flip that switch, nothing comes on, right? You do your analysis. Did the light come on? Did the light go off? If the light came on, great, that's your analysis. If the light didn't come on, that's your analysis. The next one is draw a conclusion from that analysis. So you're going to analyze the data from the experiment, draw a conclusion. The light stayed off, or the light came on. If the light came on, great. The hypothesis was correct. The light came on. If I jiggle the switch, light came on, it just means that it was a short circuit in the switch. Or the light stayed off. Now, if the light stays off, I have to go back. Up here somewhere, I have to go back to my knowledge. Now, my knowledge tells me I know that, okay, it's not the switch, it's probably the light bulb. And so I go to the hypothesis again. If I change the light bulb, then the light will come on. Experiment. Squeaky, 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 squeaky. I change the light bulb, and then I go through and I do my analysis. I turn the light switch, draw a conclusion. Light stayed off or light came on. Light came on, I'm done. Light stayed off. I have to go back to my knowledge. Now, how many of you really know what to do next? How many of you have a knowledge of electricity to know what to do next? I know most of you are thinking, oh, I just called the electrician. Well, the electrician has more knowledge than you. But the next step, let's say I actually know what to do next. I would go back and I'd say, all right, I'm going to go check the circuit breaker. Maybe the circuit breaker tripped. And so if I go back and I switch on the circuit breaker, then the light will come on. I go back and I do it. I analyze, I turn on the switch. The light came on, great. The light stayed off. I go back to knowledge. Now, here's where science really comes in. This is where all the information in your textbook came from. If I don't know what to do, I'm going to call somebody, right? that actually has to do it. Now the problem is that costs money. I'm going to call an electrician. That costs money. What does the electrician have that I don't have? Knowledge. The electrician will go through his steps. Now, what if the problem is the electrician can't figure it out? Well, he's going to call somebody else. What if they can't figure it out? What if it's a problem that's never been asked before? We've never faced this problem before. So we finally are going to have to do research. Right? And so we're going to have to do some research. We're actually going to have to research what we have to do. And we do this all the time. We naturally, if you don't know how to do something, you naturally go and Google it and check it out on the internet and see if you can figure it out. And so if I'm doing research, now all of a sudden I can ask new questions. I can go back and ask a new if-then statement and try to go through an experiment, analyze my data, and draw a conclusion about it. And that is what's happened over the years, over the centuries. Scientists have been doing this for a very long time. That's why that textbook that you have in front of you has all that information. It's because scientists, they learn a knowledge from other scientists and then they pose new questions and do new research. And that's the scientific method.